so deciphering oil labels. Cold pressed is, these are in like order of importance. No, yes they are. So cold pressed would be, like we saw that little clip last week of the coconut oil being pressed between two, oh you're funny, between two, it's in the yogurt. It's in the, they don't sell it at Big Y, they sell it at Statins shop. Yeah, in the organic section in the freezer. Between two plates under a lot of pressure, there's minimal heat at under 120 degrees. I don't know why there would ever be any other than just caused by natural friction of things. Raw cold pressed would be, I have never seen this label, but apparently it's a thing. That would be, they guarantee that it's under 115 degrees, allowing for enzymes to be intact and yeah, but again, cold pressed is cold pressed. I don't know. Expeller pressed is also another type of cold press. This would be more of like a corkscrew type of thing rather than two plates, but it's still cold pressed, so it's still a superior oil. But the problem is, hey, good. The heat here is a little bit less controllable. This was interesting that I didn't know. Extra virgin means cold pressed.
Oh yeah.
Had no idea. I just thought it was like the type of olive. I'm like, oh, that's interesting. So extra, the extra part is it's the first press of the olives. So it is the better oil. If you're going to get extra virgin or virgin, get the extra virgin. It has all the minerals and nutrients, or the minerals and vitamins in it that are natural to the plant. Virgin, still cold pressed, but it's just not as nutritive. It's not going to be the first press of the olives. So they press the olives, get all of it out, and then they'll repress them because there's still stuff left in it. Like with our juicer, we can do that. Like, you know, you leave pulp in the things. We have a cold press juicer. You put the veggies in through, you press it. You can put more veggies through and press it again with the pulp, so you can keep pressing it. And you just get less and less out of it every time. Unrefined oils, these are going to be your hemp and your flax. They are also still cold pressed. They are extremely high in nutrients. They are a no heat kind of oil. This is what you put on your salads or you put in your smoothies. We'll talk about why on the next slide. So like an unrefined cold press would be something that would be a really terrific oil. Coconut oil, you'll find this a lot. You will also see refined coconut oil. So it's on the shelf in the grocery store. Coconut oil next to it will be hard at room temperature, and then the refined one will be liquid because they've done something to it to change the molecular structure, so now it stays liquid at room temperature as opposed to solid. So refined will have a high heat point. Because all of the nutrients have been removed from it. The nutrients, the vitamins, and the minerals is actually what oxidizes when you heat it. So that is why when you remove them, now you are able to increase the heat point pretty high without there being any sort of issue. So rancidity and loss of antioxidants, which are high in a lot of oils, happens with exposure to air, light, or bacteria. This is why a lot of oils are in dark green bottles, because you want to minimize light exposure. Oxidation happens when an oil reaches its smoke point. If an oil reaches its smoke point in the pan, or if an oil smokes in the pan, that's the smoke point. Throw the oil out and start over, because what you're doing is you've oxidized the oil. So you're creating free radicals. When you do that, you eat that, and free radicals are kind of like, I don't know, I see them as like a ping pong machine like gone wrong. It's just like, you know, molecules are flying all over the place, messing with your structures inside, leading to oxidative stress inside your body, which leads to a whole host, that's like a whole cascade effect that happens. But ultimately, it creates cells that create disease and cancer and things like this. So you want to minimize oxidative stress. One of the ways that you do that is by eating antioxidants. Antioxidants eat free radicals. They're like powerful Pac-Men. So your high heat oils will be refined oils, which are bad. We don't want to do that. But your good oils that you can saute in would be ghee that we talked about last week. That's the clarified butter. I actually watched somebody on YouTube recently make it. He bought like a boatload of really good butter and just cooked it like crazy, and he skimmed all of the fat off the top when it's separated, like all that white fluffy stuff comes off, and he put it through a cheesecloth, and then he jarred it, and that was it. He left it on his counter. It's like, that was pretty easy. But you're doing that so that you can have a really good saturated fat, readily available oil that you can saute in. Coconut oil is also a good one. Cacao butter, which I have never actually used this in cooking. You can use it in baking, but you can still use it in sauteing because it's a really, it holds up well. But it's sweeter. It's not actually sweeter, but it smells sweet, like white chocolate, so it will kind of make you think sweet, like cinnamon makes you think sweet, but it's not actually sweet. Lard would be another really good one, but like not Crisco. Obviously we're talking about like actual animal fat here. The raw or no heat oils would be olive oil. Please don't heat olive oil. It has a very low smoke point, and again, now you understand what oxidation means and what it does inside of you, so you don't want to do that. Hemp seeds and flaxseed oil.
Can you talk about avocado oil?
Avocado oil does have a high smoke point, but it's a monounsaturated fat, so that doesn't matter. But yes, we use avocado. Yes, it has a high smoke point.
No olive oil, no heating.
You're not supposed to know.
All I've been
Hi.
doing.
Hey.
How are you?
Good. Okay, so
You're not supposed to heat olive oil. It has a very low smoke point. But just, you know, from like today forth. Okay. Okay, this is gonna be a cool lecture. So today is on cholesterol. So what is cholesterol and what does it do? I was astounded by all of the things that cholesterol does. Again, this is like, you know, you talk about this in nursing school, but it's not like, wow, this was really cool. So it's a waxy-like substance that's found in every single cell of your body. It actually makes your cells waterproof, so it allows for different chemistry to be on the inside and the outside of the cell. Just like an essential fatty acid or an amino acid, we cannot function without cholesterol. Like, you are a walking protein, you are a walking cholesterol. Same thing. Cholesterol is the precursor to your sex steroid hormones. So you can't have DHEA, which is a precursor to estrogen, progesterone, testosterone, without cholesterol. It is like step one, let's just say, in, you know, a chain of events that happens to produce these hormones. It is also the precursor to adrenal hormones, cortisol, which is integral to life, obviously. It controls the regulation of water balance, kidney function. It prepares us for fight or flight. We learned about that. It helps suppress inflammation. And it protects against heart disease and cancer. It is your stress hormone. Cholesterol also helps your body make vitamin D. It is necessary for calcium and phosphorus metabolism, and all of those help boost immunity. It's important for bones. It's important for your nervous system. It's important for muscle tone and mineral metabolism. Bile is also created from cholesterol. Bile is secreted, it's made in your liver, it's secreted by your gallbladder. It basically breaks down fats in your body so that you can absorb your fat-soluble vitamins from it. Vitamin A, D, E, and K. Absorption of fats and oils and fat-soluble vitamins from food, right? So, like I just said, bile breaks down fat so our bodies can access these vitamins. So, if you don't have cholesterol, you don't have bile, you don't have these vitamins. Are you like, it's that important. It's needed for proper functioning of serotonin receptors in the brain. So if you, I don't know if you've ever seen a picture, but you have neurotransmitters in your brain, and then you have on the other side of these floaty neurotransmitters, oh, that's a great magazine.
I borrowed it from you.
Oh. So you have these little like cup-shaped things that these neurotransmitters fit inside of, and that's what communicates to the rest of your brain to tell you what to do or be happy or whatever. Those cup things get their structure from cholesterol. So obviously I'm trying to make a really big point here that you think about cholesterol and you think about heart disease and that's it, but it's not, because cholesterol is obviously so much bigger than this. This was fascinating. Cholesterol constitutes over half of the dry weight of the cerebral cortex. So if you take all the moisture out, cholesterol is literally what half of your brain, the gray matter, all of those crinkly aspects, it makes up half of the dry weight of that, just cholesterol. And it's important for maintaining the health of the intestinal lining and preventing or healing leaky gut, which we know so much about. But the really big, really cool part about cholesterol is that it's basically one of your body's healers and protectors. It protects the outside of our body and the inside of our bodies from dehydration, cracking, wear, and tear. It's manufactured by a properly functioning liver from proteins, carbs, and fats. About 75% is made in our liver and 25% is absorbed from our diet. We absorb about half of the cholesterol that we take in from our diet. Cells also can manufacture cholesterol as they need it. Breast milk, which I didn't know this, is really rich in cholesterol, and the enzymes that the babies need in order to utilize it, it's because it's super important for development. Obviously, if it's half the weight of your cerebral cortex, then it's going to be very important for development. Kids and babies require cholesterol-rich foods for development of the brain and the nervous system.
Okay, so you may already know that the body makes cholesterol, right? It makes a lot, 3,000 milligrams every single day. That's equivalent to about 14 eggs, the cholesterol in 14 eggs, the cholesterol in 300 strips of bacon, or the cholesterol in about a pound of butter.
Every day.
That's a lot of cholesterol. Now, why does it make so much? Well, it's there to provide raw material for cell membranes. Half the cell, all the cells in the body, are made out of cholesterol. And you have 100 trillion cells. That's why we need so much cholesterol. So it's part of the structural property of a membrane around your cell, which allows exchange back and forth. Nutrients and vitamins and minerals and glucose and all sorts of things. So it also has antioxidant properties. It prevents free radical damage. It has anti-inflammatory properties. It makes vitamin D. It's the precursor, the building blocks for vitamin D. It actually helps you make bile that then helps you dissolve the fat and extract the fat-soluble vitamins from the fat that you eat. Very important. Without cholesterol, you can't have that happen. Cholesterol is there to make the stress hormone cortisol. And cortisol is essential for life. And all the sex hormones, testosterone, estrogen, progesterone, are all made from cholesterol. These are the normal functions of cholesterol, but you have additional functions that a lot of people don't know about, because cholesterol also responds to crisis. Like if someone has an infection in the body, cholesterol will go up because it binds and inactivates bacterial toxins. It also prevents the damage from microbes. It also acts as a band-aid. So in the cell membrane, you have the endothelial layer, which is the layer around the inside of the blood vessel. Okay? And that actually has little pores that exchange back and forth. White blood cells, nutrition, things go back and forth. So if you were to get a little tiny lesion, ulcer, damage from various things, which I'll cover in a bit, the cholesterol is there to go in there and help heal and actually to provide a band-aid. That's the real purpose.
So lipoproteins, you have HDL, LDL, and VLDL. High density lipoproteins, low density lipoproteins, and then very low density lipoproteins. The center of this, So cholesterol is not a fat. It's actually an alcohol that behaves like a fat, but it's not a fat. It doesn't dissolve in blood, water, anything like that. So your body needs to create kind of a package for it to be able to transport to where it needs to go and from where it needs to go in your body safely so that you don't have issues. So that's what a lipoprotein is. It's made up of phospholipids and it's made up of proteins. The proteins are specific to the type of molecules that it's carrying around. And yeah, so the core is generally cholesterol and triglycerides, and depending on that concentration, it makes it either high density or low density. Phospholipids and protein markers make up the outer layer. These allow cholesterol to be transported through the body. Triglycerides, when you get a total, like when you do a lipid panel, when you have your labs done and you have a lipid panel done, triglycerides is going to be part of that. Triglycerides is not a cholesterol, however. But it is important. Do we remember what makes up what triglycerides come from? If you go back a couple lectures to your sugar.
Is it the trans fats?
Yes, but part of it. So not really, sort of, yes, but it's bad stuff. So all sugars, basically, right. So all sugars basically get stored in your body as triglycerides. So when you're looking at your labs, if you're looking at the triglyceride, think sugar. If your triglycerides are high, you're eating too much sugar. That's it, period. So triglycerides are a fat that are part of your basic, okay, so yeah, so your body converts it, right, into fat storage. We talked about that, like if your muscles and your cells that need glucose are too full, it gets transformed into fat. This is what it's talking about. So your total cholesterol is made up of your LDL plus your HDL and then a 20% of your triglyceride level. Remember, triglycerides are stored refined sugar, carbs, flours, alcohols, basically anything that gets broken down into sugar is what a triglyceride is. So HDL, they're high-density lipoproteins. These are higher in concentration of proteins and phospholipids and less in triglycerides and cholesterol. So that's the differentiation. These actually behave like scavengers driving around your body trying to pick up cholesterol from when a cell breaks down, right? So if a cell is, a huge part of it is made up, the structure of it is made up of cholesterol. When the cell dies, which all cells do, right? What happens to all of that? You need to have some sort of a waste management system running through your system to clean up the mess that's left over by these cells that die off. And that's what high density HDL is. It goes around into your body from your liver and it picks up the cholesterol left over by cells that don't need it anymore or they've died. They bring it back to your liver. They go out and pick it up. That's what they do. So you can liken these, the example was a hybrid car, but I know hybrid cars kind of give a false sense of like environmental friendliness, so I changed it to a pedal car because they're like super environmentally friendly.
Fred Flintstone.
Right, exactly. Kind of a pain in the butt, but like they don't have any emissions, right? So you can liken these to the pedal cars in your body. They're low in emissions and better for your environment because they're cleaning everything up. LDL, this is the confusing one. So, but it's not going to be confusing after today. So this is your low density lipoprotein. They're lower in density of proteins and they're higher in concentration of cholesterols. They transport cholesterol and triglycerides from the liver. Oh, I lied. Remember when I said that HDL goes from your liver out to your body? Basically, HDL is completely empty and it goes out and picks up cholesterol. Okay? I didn't lie. I just didn't say that. So HDL leaves your liver empty, goes and picks up cholesterol, brings it back. LDL leaves your liver full of cholesterol, drops it off where it needs to go. Okay, cholesterol and triglycerides from the liver to the cells and tissues for uptake by those cells for metabolism within the cell. Cholesterol is a healer. We'll get into that a little bit deeper in a second. When LDL levels are high, it's generally an indicator that there's something going on inflammatory-wise within the body that cholesterol is tending to. So if cholesterol is needed in your body, there's something going on because cholesterol needs to go in there and kind of quell inflammation. So that's what's happening. Yes, you can liken these to a classic convertible Mustang.
Nice.
They are higher in emissions, not terrific for the environment, but exactly to your point, their existence is very critical for heart health and for overall happiness. Like there's a group of gentlemen that even in January will meet on the green at 7 o'clock in the morning and they'll bring their classic cars and they'll set up their lawn chairs in January and they just sit around talking and they bring their classic cars and that's what they do. Like their hearts are happy because they have these probably ridiculously poor gas miles per gallon in gas, beautiful cars. So it's great. They're classic. You see one, you're like, wow, that's beautiful, but like you can't have a whole highway full of them because then you have a lot of congestion and a lot of smog and you don't want that. So, they're just not good in large numbers. VLDL, these are very low density lipoproteins. They're large and fluffy in nature and their job is to transport triglycerides straight to adipose tissue for storage. You can liken these to pickup trucks. They're important for transportation of products, but not good for the environment.
Hey guys, Dr. Berg here. Listen, out of all the videos that I've done, this is probably the most important video, and you'll see why. Because there's so much confusion, so much false information, that it's very complex for people. So I want to break it down step by step. It's a little bit longer, but it's very important. So we're going to answer the question, is the so-called bad cholesterol, LDL, really that bad? Okay. Well, first of all, LDL is not cholesterol. In order for it to transport cholesterol through the body, which is, fat doesn't mix with water. It just doesn't mix. So the body has developed little shuttles or different particles or vehicles to transport cholesterol. Okay. And you have LDL, low density lipoprotein, and you have HDL, high density lipoprotein. LDL, which is considered bad, really is a kind of a misnomer because LDL really is the cholesterol that goes from the liver to the vascular system to the cells. So it's going through into the body, okay? HDL is the opposite. It's going from the vascular system back to the liver to be recycled or eliminated, okay? So really, these two types of proteins are exchangers that are just constantly working together to exchange cholesterol back and forth to transport cholesterol and triglycerides, which are blood fats, okay?
So HDL leaves your liver and goes and picks up random cholesterol out in your cells, but at some point, HDL can get, those high density lipoproteins can get full too. So at that point, the low density lipoproteins and the very low density lipoproteins can get left out in your arteries and can't get picked up if there's too many of them, and that will tend to cause a problem. They can oxidize and that leads to more problems down the road. This is part of the process that leads to plaque formation. This is an overview. Since the liver controls the production of cholesterol, oh, didn't I say that? Since the liver controls the production of cholesterol, increased cholesterol isn't necessarily an indication of heart disease, it's an indication of liver function. Did I say that? No, I didn't, okay. All right, so, everybody thinks that cholesterol numbers are going to be an indication of heart disease, which in some very small aspect is true. But because cholesterol is primarily produced in your liver, it's going to be an indicator of how your liver's doing rather than how your heart's doing. High cholesterol causing a heart attack is going to be a symptom and not an actual root cause. something is out of balance that's creating a plaque. And we're going to get into it. There's a very awesome here. This is atherosclerosis. This is a very great description and drawing and everything of what actually a heart attack, a myocardial infarction is, what it looks like, what's going on the inside. He does talk about cholesterol. This is primarily what it's about, but you'll understand a lot more.
So here's our blood vessel there, and now I'm drawing the 3 layers of the wall of the blood vessels. And on the very inside of the blood vessel, as part of this pink layer here, we have a single layer of cells called the endothelium. So let me just draw out the endothelium here. And although it's just a single layer of cells thick, the endothelium has a lot of really important roles. One of its really important jobs is to act as a barrier. And it acts as a barrier between stuff that's in the blood and the rest of the blood vessel wall. So stuff can't just pass through and get into the rest of the blood vessel wall. And this barrier function will become pretty relevant in a minute. You'll just have to take my word for it for now. And another really important job that the endothelium has is to secrete proteins onto its surface that prevent clotting, that keeps blood flowing nice and smoothly. So those are 2 of its major jobs. It has a couple more, but those are the ones that are relevant in atherosclerosis. Alright, so you remember that big fatty vessel from before. Well, how do we get from this, our nice clean blood vessel, how do we get from this to that? Well, let's take a look. Well, the first thing that has to happen is that there has to be some irritant present. Something in the blood that's going to predispose this atherosclerosis to happen. So what are some irritants? Well, things like too many lipids, so specifically fats and cholesterol, LDL cholesterol, the bad cholesterol. And let's actually put some of this cholesterol in the blood vessel so we can just see it really clearly. And I'll just label it LDL, LDLC actually, so you know this is cholesterol, LDLC. Another irritant, probably the worst one, is toxins from cigarette smoking. So we'll put some toxins in the blood from cigarette smoking. We'll do them in gray here. And another major one is just hypertension, high blood pressure. So we'll try to show that pathologically high blood pressure here by these arrows. High blood pressure. And this means high blood pressure. And I'll actually write hypertension here because I just want to make it clear that it's the chronic exposure to high blood pressure. It's not just, high blood pressure every once in a while. So that's our first step, to have an irritant present. And our second step is to actually have damage to the endothelium by the irritant. And so our barrier now is broken down. It's started to break down. So that's step 2. That's actual damage of the endothelium. And in step 3, regardless of whatever damaged the endothelium, I mean, if it was toxins or if it was the cholesterol or if it was the high blood pressure, regardless of what actually damaged the endothelium, what happens next is that the cholesterol will jump in there and start to collect under the damaged endothelium. So let me actually clear away some of this because we're going to focus on the cholesterol now. So this is cholesterol and it's going to sort of settle in here. It's going to think to itself, hey, that looks pretty comfy. That looks like a cozy place to be. So I'm going to just jump in there. And of course, these are coming from inside the blood, right? They're not just sort of multiplying. They're floating around in the blood, and then when they come across this damaged endothelium, they're going to join their friends. And when they build up to this sort of flattened extent here, they're known as a fatty streak. So one thing that happens to the cholesterol when they get inside the wall of the blood vessel there is that they start to get oxidized. They sort of change a little bit. And when they change, when they get oxidized, that sends a signal to the immune system, to our body's immune system. And that signal will bring around these cells of the immune system called monocytes. So they'll sort of show up almost like police. So here's a monocyte here, and I'll draw it in white to remind you that it's a white blood cell. And this monocyte doesn't really like that the cholesterol is starting to collect in the blood vessel walls. So the monocyte will actually chase in after the cholesterol to try to break up the little party that they're having. And so I'll actually draw what happens next down in this next bit of the blood vessel down here. Just so we can keep in mind all of the past events. So you may have noticed that I drew this white blood cell to look like a Pac-Man sort of thing, eating up this cholesterol, because that's essentially what it does. Once it gets into the endothelium, it converts into something called a macrophage. Macro meaning big and phage meaning to eat. So it's really this big eater its job here is to devour that LDL cholesterol that's collected in the endothelium. Unfortunately, things don't go as planned for our macrophage because what ends up happening is it starts to gorge itself. The macrophage eats so much cholesterol that it just sort of becomes too full of these yellow cholesterol drops and it sort of dies off. But it's full of cholesterol, and someone a long time ago looked down a microscope and thought that these dead macrophages filled with cholesterol looked like foam, like sea foam that you see at the beach. So these dead macrophages filled with cholesterol are now called foam cells. So let's catch our list up. And remember, these foam cells were actually white blood cells. So when they die, they release these signals that sort of call in reinforcements. And I'm going to use that to remind you that atherosclerosis is primarily an inflammatory disease. It's an inflammatory condition. And so when these foam cells release their cytokines, their signals, they call in reinforcements, and the whole process sort of proceeds in this vicious cycle, as you'll see. And don't forget that LDL is also still being deposited into the wall from the bloodstream. And as part of this inflammation, more and more endothelial cells get damaged. So I'll move our drawing down even further so we can look at the next sort of development. And so you can see this mountain of cholesterol and foam cells, dead macrophages that are filled with cholesterol. You can see this mountain just keep on building and bulging out into the middle of the blood vessel. And so by now things are just way out of control, right? And these guys in here, this is the smooth muscle part of the artery, by the way. So this is the smooth muscle layer. These guys start to take notice, these smooth muscle cells. So what ends up happening is that you get smooth muscle cells that sort of migrate out of the smooth muscle layer, and they sort of migrate. I hope you can see this. I'll draw them a bit thicker. They start to migrate out of the smooth muscle layer and into the fatty plaque here, right? Because they can sort of sense that something's just not quite right. And what they start to do is they really want the plaque covered up because they don't want the thrombogenic, remember thrombogenic means clot forming, they don't want the thrombogenic plaque to be exposed to the blood. So what they start to do is they start to secrete a fibrous cap. They sort of spit out this collagen and elastin protein cap that covers up, right? So I'm drawing it in purple, that covers up this plaque and shields it from the bloodstream. And that's called a fibrous cap. And they also do something else. The smooth muscle also do something else. So you remember these foam cells that died in here? Well, when they release their signals after they die, they induce the smooth muscle into depositing calcium into the plaque. So I'll draw that in. I'll draw in these little calcium crystals now. So you can see it's just starting to look like a mess in here. There's just all sorts of stuff going on. So again, this is really not something you want to have happening in your body. And so just by looking at this, what can we say is happening to the blood vessel? Well, I mean, we can see this huge bulge. We can see that the plaque is obviously bulging into the blood vessel, and it's probably going to restrict the flow of blood that can get through here. So that's one thing that atherosclerosis is doing. It's occluding, it's blocking off the arteries. The second thing is, well, look at this calcium. I mean, if there's one thing we know about calcium, is that it's really tough, it's really hard. And so this by the smooth muscle laying down calcium, that's one of the ways that atherosclerosis makes your arteries really hard. And that's actually part of the name. Atherosclerosis actually means hardening of your arteries. But I think in terms of coronary artery disease, the biggest reason that atherosclerosis is bad is because it can cause complete blockage of the artery. And that blockage of the artery can happen because sometimes this plaque, this fatty plaque, it can rupture. And when it ruptures, all this thrombogenic plaque material gets exposed to the blood. And when it gets exposed to the blood, it starts to form this really big blood clot in the middle of your artery, in the middle of one of your coronary arteries. So let's just draw that in here. Let's just draw this big blood clot. Pretend that this has been ruptured.
So basically, what happens from here is this ruptures, it causes more platelets to come, and that whole entire vessel gets occluded. This drawing is from this little cross section right here of the coronary arteries. This is your heart, so these are the arteries that are actually feeding your heart tissue. So if one of those becomes blocked, all of the tissue and muscle below that will die, and that is actually what a heart attack is. It's called a myocardial infarction, meaning muscle tissue death, lack of oxygen, no oxygen. All right, so what causes high LDL? Factor fiction. Does eating dietary cholesterol increase your blood cholesterol? Martin, how about you answer? What do you think?
It does not.
You think it does not. You're right. Fiction. All right. So this is the, remember when he was talking about the, when he said the LDL-C in there? Well, apparently there's two different types of low density cholesterol. There's type A, which is like large, buoyant, fluffy molecules that in the area of the tissue that was damaged, they would have been too fluffy to fit in there. They don't really damage anything. They float around the bloodstream. They're not sticky. They're not small enough to get lodged into the artery lining. A really good analogy is like if you think of one of those frying pans, like a Teflon, not Teflon, but what's the, you know, a non-stick frying pan. That is what the inside of your artery is like. You can put oil in there, it won't stick to anything, it wipes right off, no problems. The second you get a scratch on that, however, and that lining is damaged, everything gets stuck to it, right? And then you have like black streaks in there and you can't get it out, and now your pan is just falling apart and it starts to crinkle all the other stuff, like all the other non-stick particles off. That is a great description. A large, fluffy cholesterol, LDL, won't get stuck on there. But, these also, side note, these are increased with saturated fats. They only stick around in your body for about 2 days before your body metabolizes them out. So, really fine. Type B, these are small, dense molecules. This is the molecule that you saw in this, the little yellow ones that were getting stuck in the intimal lining of the vessel. So these invade the endothelial lining due to injury. They're trying to come in and heal it. Because again, cholesterol is what makes up the structure of cells, right? So cholesterol is being called there because there's injury. Oh, I need to fix the structure of this cell, so let me go, except they don't, it just goes kind of haywire. So these are increased by eating refined sugars, refined carbs, seed oils, like we talked about, like you had said, Teresa, corn oil, canola oil, soy, mayo, salad dressings. These are in a lot of salad dressings, like conventional salad dressings. Smoking, like he said, junk food, stress, low vitamin C, surgery, because you have trauma, so your body's making more cholesterol to try and heal all of the internal damage that was done, right? Trauma. Trans fats. They are high in triglycerides and low in HDL. Oh, so in your labs, when you have a lipid panel drawn, a basic lipid panel, you will not get the differentiation between these two. You will just have HDL, LDL, triglycerides. So if you only have that, a good way to see, okay, is it the bad LDL? Or is it the LDL part that I don't really need to worry about? A good way to differentiate would be if your triglycerides are low and you have a high HDL, it's the fat, fluffy ones, no problem. Other way around, if your triglycerides are high and your HDL is low, then you are then probably tipped off to the fact, oh, I need to decrease all my junk food eating, because that's a really fast way to reverse these numbers, okay? Or you can get an advanced lipid panel. You can just ask, please draw an advanced lipid panel, and right on the lipid panel it'll say this SD-LDL-C, like where he drew LDL-C. It'll say this on your lab, small density, like we talked, like small density, small dense molecules, small dense LDL-C. There you go. all labs will give you a range, so you can just see what the range is. And again, the remedy for this is lifestyle and diet. So vitamin E is one of your fat-soluble vitamins that I keep talking about. It is responsible for protecting the inner layer of your blood vessels. It's severely depleted on a SAD diet, standard American diet, thus further contributing to the poor integrity of the inside of your blood vessels. So just, more reasons why you would have reason for this type of plaque forming that we just saw to happen would be standard American diet causing just the overall integrity of your blood vessels to decrease. I thought it was really
Okay, so now the question
cut it off.
is, why would someone have high LDL pattern B? Okay, we already talked about the sugar, right? Because sugar creates inflammation, it's very destructive to the cells. That's why diabetics have a lot of nerve damage, vision problems, inflammation, coronary heart disease. So sugar and refined carbs are really, really bad. Okay. Also, low thyroid will create it. High cortisol will create higher amounts of pattern B stress. Vegetable oils, the soy and the corn oil and canola, all that GMO, that's vegetable oils, that's high in omega-6 fatty acids. That creates more inflammation in the body. Trans fats, hydrogenated, partially hydrogenated fats will do it. Low vitamin C, just like a situation when you get bleeding gums, you get bleeding arteries. Glycation, what is glycation? That's when you combine glucose or fructose with a protein or a fat. So let's say you take barbecued sauce and you put it on some ribs and you bake it, you heat it over 200, I think, and 48 degrees Fahrenheit. You're going to get glycation. So the glycation means that it's this combination of sugar with protein that goes in the body. It's very sticky, and it starts creating high levels of pattern B, among other issues as well. Fries, so they take sugar and they spray it on French fries, they deep fry it, same deal. Donuts, deep fried donuts, glycation. What's interesting is, when you combine protein with sugar or sugar with fat and you bake it or you cook it, you create glycation. Also, when you consume high fructose corn syrup or fructose in the form of refined fructose or tremendous amounts of fructose, you can increase glycation by 10 times, okay? Because it combines in your body. So not only does it have to be, external, it can be internally as well, okay? And then surgery will increase pattern B because LDL is a healer. It's trying to go in there like an ambulance and actually fix things. That's the purpose. It's trying to help you. And what do people do? They take a statin. They try to eliminate it, not understanding why we need LDL. Visceral fat will also trigger pattern B as well. So anyway, those are the things that will increase the real, it's not bad cholesterol, it's the cholesterol that's involved in the crime scene, in the damage. All right. Okay, in summary, we just want to understand cholesterol, LDL, what it is and what it's not, and use as an indicator to pull a string to find out why it might be high. If it's higher, it could be normal if the triglycerides are normal and the HDL is normal. But if there is a problem with these, then you have to ask, why? Do I have a hypothyroid issue? Am I eating too much sugar? Am I doing this? Did I just get done with some surgery or trauma? All right? Thanks for watching. Put your comments below.
So just coming from the cholesterol standpoint, does this make everybody feel a lot more comfortable with labs? Because, it's not like your doctor really even goes over this stuff. Farm to table. I really liked this name. It comes from a program. Basically, it's statins versus lifestyle. Pharmaceuticals versus the table. This is such a brilliant... Does everybody heard of Voltaire? He's a 17th century philosopher, really prolific writer. So this is his quote. Doctors give drugs of which they know very little into bodies of which they know less to treat diseases of which they know nothing at all. I was like, wow, that's profound.
yeah.
And a really great example of this would be the drug classification of cholesterol lowering medications, of which statins is one of them. So statins are promoted as protecting the heart pump by lowering cholesterol, thus reducing illness and mortality in those who are at high risk of cardiovascular disease. So let's not make any mention of changing diet, lifestyle, stress management, how important sleep is, water consumption, all of those things that we've talked about pretty much throughout every single topic that we've touched on. Those are all constants. They don't talk about any of that. Let's give you medications. So how do statins work? In our body, we have two different pathways for cholesterol. One makes cholesterol, and one breaks it down. We've talked about that. Statins affect the pathway that makes cholesterol in the body. They stop the process at step 1. There is a very lengthy process in your body as to where cholesterol, how you get cholesterol, how it's made. If it's a 10-step process and your end result is cholesterol, statins come in at step 1 and they block it. The problem is that you're blocking all of those other downstream effects, all of those, what I opened this lecture with, those 3 pages of everything that cholesterol does for you. You're blocking all of that. So wound healing, fertility, embryo development, your body's ability to kill cancer cells, hormone regulation, cell membrane integrity, bile production, vitamin D production, everything, right? We talked about how important it is in brain tissue. Like, that's a big factor here. So remember this, because it's pretty sad, actually. So the number one complaint about people who take statins, does anybody know anybody who takes a statin? Yes? No?
Sure.
Maybe?
Yeah.
Okay. So a really famous type of side effect of this is muscle fatigue and weakness. It's a really common complaint. Your lack of cholesterol in your muscle cell maintenance leads to cell damage and death. So if you don't have cholesterol helping with the integrity of your cells, right, you're going to have weak, flimsy cells that are going to die. Muscles obviously use a lot of cholesterol because that's what our active functions come from in our body. So if you're blocking the production of that, you're going to have issue. The big problem that really comes from this, and it's not common, but it's more common than not, and the FDA has strongly documented this specific side effect. When a muscle cell dies, it spills out all of its protein and electrolytes into the bloodstream. A high protein in your bloodstream has to be filtered out by your kidneys. Your kidneys don't like high protein. That's why like high protein diets or where are you getting your protein? Eat a lot of meat. They really do a lot of damage on your kidneys. The condition that this eventually leads to is a crazy condition. It's called rhabdomyolysis, which is basically just massive muscle cell death, and your body is just kind of falling apart from the inside. Liver damage follows kidney damage. These are your two massive filters in your body, so if your kidneys are not functioning at full capacity because they're overworked and they're starting to fail, then everything's going to back up, and then now your liver is going to start getting involved. Other common complaints are brain fog, so bad that it mimics Alzheimer's, salinity, going senile, disorientation, forgetfulness, confusion, and amnesia. When I was listening to my lectures, she was talking about specifically a doctor who was taking Lipitor, which is the #1 statin drug. And he took it once, and after a couple of months, he had complete amnesia, like no short-term memory, didn't remember marrying his wife, nothing. So then his doctor took him off of it for some reason, and then he had to go back on it like a year later, and the same thing happened, like for quicker this time. So he knew it was the statin drug that had caused it, but that's like, you know, really kind of crazy. Think about it. I remember when I worked in nursing home, long-term care facility, a nursing home, I think most of my patients were on these, and most of them had dementia. So it's not the cause, but it's like one of the multiple reasons why we have such altered levels of consciousness in elderly patients. Digestive problems, constipation, diarrhea, and indigestion. So to recap, statins do lower LDL, they do, but they also produce some pretty damaging side effects. They don't increase HDL, which would be something that you would think that they would do. Like, okay, let's get the HDL out there so it can pick up all of this extra stuff. No, there isn't a drug that does that. Or decrease the triglycerides. Let's decrease your triglycerides. Nope, doesn't do that. High triglycerides and low HDL are more effective markers for coronary artery disease than high LDL, which we talked about, and then Dr. Begg. Just as really cool as cholesterol is, so is CoQ10. Have you guys heard of CoQ10? Right. So its other name is ubiquinone, and it is a super, super antioxidant. It's named because it's ubiquitous presence in all human cells. Like it's in everything. And it's naturally occurring. It's a coenzyme, which is basically a small molecule that has to help in an action of another enzyme in order for something to happen in the body. So CoQ10 is ultimately responsible for the production of ATP, which is the adenosine triphosphate. It's actually what energy is, and what the name of energy is that comes out of your mitochondria. It's where you get your energy from. It is energy. These are the molecules of energy, is ATP. So CoQ10 is responsible for the production of energy. It is a coenzyme. If it's not part of the process, then you don't have ATP production. Energy and cellular functions hinge on the presence of this naturally occurring CoQ10 within the body. All of your cells utilize CoQ10 to produce energy needed for life. CoQ10 is considered the longevity nutrient, and it is critical, with critical implications for your immune system and mental health. That makes sense, right? Because your immune system definitely utilizes a whole lot of energy, and your brain, how much, I don't remember how much energy your brain utilizes. It's like 25% or something. Like it's a lot of your daily energy is just for your brain.
Mine doesn't utilize mine.
It's phenomenal how much it utilizes. So once you reach 45, your body's only producing a fraction of CoQ10 that it did in your 20s. So if you want to add a supplement just for ha-has, you might want to jump on this bandwagon. If you want a recommendation for one, reach out and I'll send you one. So there's over 1,000 research papers, 39 placebo studies, and scientists in over 18 countries that agree on the fact that if your CoQ10 levels are depleted, you're leaving yourself wide open for accelerated aging, disease, and deterioration. Degeneration is what I was going to say. Basically the same thing. Deterioration.
Oh.
So guess what statins do to CoQ10?
Deplete it.
They block it.
Eliminate it.
The biological pathway that makes cholesterol for our body is the one that the statins block, is also the pathway that is responsible for producing CoQ10. So this pathway it creates a lot of other things on its way to making cholesterol as byproducts. CoQ10 is one of them. Well, statins block this pathway. It's step one. So you're not getting this. So symptoms of CoQ10 deficiency, remember back to what the side effects of statins are. You have a myriad of heart problems, obviously, because your heart utilizes a tremendous amount of energy. Arrhythmias, anginas, hypertension. HTN stands for hypertension. Sorry about that. Difficulties regulating blood sugar and stomach ulcers, reduced energy, chronic fatigue, shortness of breath, fluid retention, frequent urination, myopathy, which is basically issues related to your muscles, like we talked about with statins causing weaknesses in your muscles. Well, they're not getting the proper energy needed. Weakness and fatigue, and many more. They're all synonymous with the side effects of statins. So conventional doctors are now actually recognizing this and prescribing or recommending that patients take CoQ10 in conjunction with their statins. Like that's how, I mean, medicine obviously, things take like 10 years or something like that for them to actually change it within the office. So yeah. So here are some action steps, right? But I bet you guys kind of already understand this and get it because they're definitely the action steps that we've been learning all along the way. Eliminate trans fats. And zero should mean zero, like we talked about last week. Trans fats are allowed up to 500 milligrams per serving, and they are allowed to say zero trans fat on the, even though they're allowed to say zero trans fat on the nutritional label. So you must read the ingredients. It cannot say partially hydrogenated or hydrogenated anything in the ingredients. Consume high omega-3 foods, wild-caught salmon, sardines. I don't think they farm-raise sardines, do they? They don't.
No.
No. Leafy greens, flax. That says flaz. Flax, hemp, and chia. That's a cool word. Flaz. No seed oil. They're high in omega-6s, which cause inflammation. Canola, soy, and cotton. A whole food diet. High quality animal products only. Increase your fiber. Cholesterol is kind of washed out of your system with the help of fiber. So a high fiber diet is going to help with bile secretion, is going to help get rid of excess cholesterol that's hanging around in your system. Lower your glycemic load. So select fruits would be fruits that are lower in your glycemic load, not necessarily your glycemic index, your glycemic load than other fruits. Like a banana would be really high, but berries are really low. Berries are phenomenal fruit. They are packed with phytonutrients and antioxidants, which are super critical for fighting all of this stuff. And they are very low in sugar. And then choose natural sweeteners because they have more constituents and they have a lower glycemic load. Like maple syrup's got a really low glycemic load, coconut sugar, stevia, brown rice syrup. And exercise. Except I wrote that with like 17 exclamation points. Exercise! Regulate stressors, increase your quality of sleep. Magnesium is a great supplement that also helps with inflammation that we've talked about, over the past couple of months. Always eat a healthy break fast, a breakfast. A breakfast does not have to be in the morning. I don't generally always eat breakfast until maybe like 11 or 1, depending on, but it's when you break your fast. That's what it stands for. So whenever your first meal is, make sure that it's a healthy one and it's not, got a whole bunch of syrup on it, because you want to start off in a really calm metabolic state and not one that's super jittery, causing your body more internal stress. And talk about some supplements and herbs like a CoQ10, magnesium. Curcumin is like, everybody should be taking this as well. It's the phytonutrient in turmeric. So you've all heard that turmeric is a super high anti-inflammatory. It's because of the curcumin in the turmeric. This is the important component of turmeric. It is a super antioxidant. It goes after everything. Everything. It's really super powerful. Green tea is really, what's the word? Flavonoids. It's really high in flavonoids and antioxidants. Goji berries, acai berries, like I said, berries are really, we had goji berries a couple weeks ago, right? I brought them in.
With the chia.
Huh?
With the chia seed.
Yeah. And your fat-soluble vitamin, well, vitamin C is not fat-soluble, but vitamin E, you can take vitamin C and fish oil. And we're done. Look at that. Wow, that was impressive. I feel like I should do it all over again.